This is chapter 6, number 3. And it says a factory worker pushes a 30-kilogram crate, so 30-kilogram crate, a distance of 4.5 meters along a level floor at a constant velocity by pushing horizontally on it. The coefficient of kinetic friction between the crate and the floor is 0.25. So part A asks, what magnitude of force must the worker apply? So the magnitude of force that the worker must apply is going to be the so friction is going to be the same as friction. So friction equals, this is A, friction equals the friction coefficient times the normal force. So that's going to equal 0.25, that was our friction coefficient. And then the normal force is just going to be gravity times the mass of the object. So there's that. Then the mass is 30, and gravity is 9.81. And that's going to give us, once we round to sig figs, 74 newtons. Now, what's important here is that before we round, the actual answer we get, so I guess this is squiggly, what it really equals is 73.575. That's going to be important in a minute. So then part B says, how much work is done on the crate by this force? So we just solve for force, which we know work equals force cosine theta x. So we're just going to plug in our values for that. So the force is these 74 newtons. The cosine, since it's in the same direction, it's going to be the cosine of 0, which is just 1, so we just don't even need to worry about that. And then the displacement is the 4.5 meters that it gave us. So 75 times 4.5 equals 74 times, equals joules. And then part C asks how much work is done on the crate by friction. So for this one we're going to do the same thing, but we're going to use this value. I don't know why it did it this way, but it did, and it's, so to get the answers from the back of the book, make sure you use this number, or when you type in your calculator, type this whole thing in your calculator again, and then times it by the 4.5, and it's going to give you 330 and negative. And that negative, we know, because friction is, if the crate's moving this way, friction is going to be pushing against it this way, so that's why that's going to be a negative work. So this is why it's weird that they do that. So then part D asks, so this weirdness will come later. D asks how much work is done on the crate by the normal force and by gravity. So both the normal force and gravity are going to be the same equation, so I'm just going to write it once. So the work is going to equal 30 times 9.81. That's the force. And then it's going perpendicular to it. So cosine of 90 degrees, because either way, cosine of 90 degrees or 180 degrees is going to be 0. So anything times 0 equals 0. So both of those will be 0. The normal force and gravity will both equal 0 because it's perpendicular to it. So that's like the mathematical way, but you can just know that by knowing that they're perpendicular. And then part E says, what is the total work done on the crate? And this is where it's weird, because in the answers in the back, it uses the rounded 74 to get this, which gives you 333, right? But then it wants the non-rounded answer to be used to get you the negative 330. So when you actually add those together, because the net force is just going to be or the network, is just going to be the sum of all the work forces. So it's just going to be 333 plus a negative, so minus 330. And that would leave you with 3. But the answer in the back of the book is 0. And that's the actual correct answer because technically these two equations would be the same, giving you 333 and negative 333, which would equal 0, which makes sense for what it's saying for the situation that it describes. So kind of weird, but that's the answer.